Welcome back everyone. So we had been discussing about writing unambiguous production rules for desk calculator grammar, and we had been understanding how production rules of context-free grammar can be written. So someday if you have to write your own parser for your own language, you'll know how to write production rules considering different set of operators. So these are the unambiguous production rules that we have already derived on our own, and we have understood that every time a new precedence rule need to be added, a new non-terminal is going to be added. Every time a new non-terminal is added, it is going to be directly derivable from the previously added non-terminal, and the sequence hierarchy of operators as well as hierarchy of non-terminals also. So we have derived these expressions. Now we are going to take a bit complicated expression, and we will be using all these rules and try to derive that expression, so that we'll have confidence enough that now we are able to use all these rules and derive the expression correctly. Fine. So let me take the expression id divided by id plus id raised to id minus id. Okay. Suppose I have to derive this expression. For deriving this expression, once again what we have to do, we have to write down the sequence of precedence, the highest precedence to lowest precedence which we are going to apply. So the highest precedence is, first of all we need to have this brackets, outer brackets that has highest precedence. The second highest precedence which we are going to have is, so see what is going to happen now. This will turn out to be a bracket inside which we have two operators only. This is the value. This is value. So don't consider this bracket right now. This is value. It is like id divided by id plus some expression. So there are two operators only inside the bracket. If you consider both operators, which has higher precedence, next highest precedence, that is 2. Okay. Now before applying plus, before applying next highest precedence is of 3. Okay. Fine. So that is next we need to have. Then what next? Then we need to have this bracket. Okay. Inside the bracket we have two operators, which is exponent and minus. So that is 5 and then that is 6. Okay. So that is how we are going to apply it. Fine. Now, so that is how we are going to have this. So actually the question that should come in your mind is, this is a nesting of brackets. So isn't it should happen that the first this bracket should be evaluated, then this bracket should be evaluated, and so on. So that we will understand as we will be applying the rules. So right now how you can read this is, there is a bracket inside which you have two operators, and this is one answer. Consider it id only. Then there are two operators, division and plus. So this is the priority. When you consider this inner bracket, then you have two operators and this is the priority. So this is how we are going to apply the operators. So to have the outer operator, first of all, means you have to reach over here directly. Without using any operator outside, you have to directly reach to P derives bracketed E. So what I have to do? E derives T because E derives T. T derives F because T derives F. F derives EXN because F derives EXN. Okay? EXN derives bracket P because EXN derives P. Okay? Then P derives bracketed E because P derives bracketed E. Fine. So that is the outer bracket that has been explored first. Fine. So the sequence we have written is the reverse one. So how it is going to be treated? Now let us see how it is going to be actually treated. So see, this is the bracket that is going to be applied lastly. In the sequence, the first we are going to apply is this. The first operator, first this, and inside which we have this and this, these expressions. So we will first understand, then we will write the precedence, so it will be more clear, as this is a bit complicated. So now we have E over here. So what we require inside it, we require division and we require first. If you consider division and plus, which one is having lower precedence, that you need to pick up first in the derivation. So lower precedence is plus. So this E should be deriving plus. So E plus T because E derives E plus T. So see, this has been explored. This has been already done. What is next remaining? Division on left side. So this E should be deriving U division. So E will be converted to T because E derives T. And then this T will be converted to division. So T divided by F plus T because T derives T divided by F. So see, division is available, plus is also available. What is required? On right side of plus you require a bracket. So what will happen now? This T will should be converted to bracketed E. So T divided by F plus T will be converted to F. T converted to F. Then this F is converted to EXN because F derives EXN. EXN is converted to P because EXN derives P, and P is converted to bracketed E. So say these brackets have been achieved. Now inside which is the lowest precedence operator? Minus. So this E should be deriving minus, exactly. So this is T divided by F plus E derives E minus T because E derives E minus T. Now this E should be deriving your exponent. So exponent is derivable for what? EXN. So F. So T derives F plus in bracket E derives T minus T. E derives T. Now further T divided by F plus this T will be deriving F because E derives F. Okay, I'll be continuing this here so you can understand it clearly. So this will be as it is. Now what will happen? This F will be deriving your exponent as we require it over here. F derives EXN raised to F. So everything as it is, T derived by F plus in bracket F derives EXN raised to F minus T because F derives EXN raised to F. Simple. So now all the operators have been achieved. See, division is there, plus is there, bracket is there, exponent is there, minus, yes. So in which sequence the operators are applied? The innermost bracket is applied first. In which the highest precedence operator is this, second highest is this, third this bracket, fourth one is this, fifth one is this, and sixth one is this. So when we applied derivation, we went in reverse. So first we had this, then 5, then 4, then 3, then 2 and 1, right? This don't work without bracket. How the operators are explored, that way these operators are not going to be explored. Coming back here, what we require, all these non-terminals need to be derived to terminal ID. So first of all T will be deriving to F because T derives F. Then F should be deriving to EXN. F derives EXN. EXN should be deriving to P because EXN derives P, and P should be deriving to, yes, ID. Because P derives ID. So see, that is what we require, ID divided by ID plus in bracket ID raised to ID minus ID. Yes, we have achieved it. So that is how we will be actually solving the expressions. Now we need to understand what is the meaning of leftmost derivation and rightmost derivation. So this is how derivation is applied. But mind that this is a generalized derivation, and there are certain, we haven't considered whether we are applying the leftmost derivation or whether we are applying the rightmost derivation. In actual practice, you have to either follow leftmost derivation or rightmost derivation. You won't be deriving like we have did, as we have discussed previously also, that you cannot apply all the derivation at once for the same symbol which you have. The same rule cannot be applied at multiple places. Just for the sake of simplicity we have done till now, but after this we are going to apply them in sequence as per leftmost derivation or rightmost derivation. So let me explain leftmost derivation and rightmost derivation, what it means. Okay, fine. So fine, for the sake of simplicity, let me take the simple productions and only small set of operators only, not all operators I am going to consider. So E derives E plus T, E minus T or T, T derives T multiplied by F, T divided by F or F, and F derives ID. I am only considering the operators plus, minus, multiplication, division. Hence, I need not to go further. The last non-terminal that I am going to use is F, so F derives ID. See, in exam, depending on which all operators you have in expression, you can decide which particular grammar you are going to use. Up to F or up to EXN or up to P. Mostly we will be using the entire grammar only. Just for explanation purpose, I am right now using the portion of the grammar. So what we are discussing right now, leftmost derivation. Okay. So let me take one expression, it will be more clear. So suppose my expression is ID multiplied with ID plus ID. Okay, and I am applying leftmost derivation. Fine. So the first rule in this expression, which is the highest precedence operator, this. What is the next highest? This. So we will go in reverse. The least precedence operator here is plus, so that should be derived first. So E derives E plus T because E derives E plus T. Okay. What is leftmost derivation? Leftmost derivation says that whenever on right hand side you have more than one, whenever on the right hand side you have more than one non-terminals, the leftmost non-terminal must be derived first. Let me repeat, what is leftmost derivation? Whenever on right hand side of the production more than one non-terminals are there. If it is a single non-terminal, there is no question. But if more than one non-terminals are there, then the leftmost non-terminal must be derived first. Must be, see, must be. Okay. So what actually you need to do over here, you need to derive this. So the leftmost non-terminal over here is capital E, that we are going to derive first. So where we have to reach? We have to reach to multiplication over here. We cannot derive multiplication from E, so E will be converted to T. Once again, what we are going to commit? That if you have more than one non-terminal on right side, the leftmost should be derived first. So this T will be deriving you to T multiplied by F. Okay, because T derives T multiplied by F. Okay. Now how many non-terminal you have on right side? 3. Which one is leftmost? Yes, this one. So that should be derived first. Do you require any other operator here? No. So what we require, all non-terminal should be deriving the terminal ID. But as we have discussed earlier, as we are applying leftmost and rightmost derivation, we are going step by step. All the same kind of non-terminals cannot be handled together. We have to go step by step. So what is going to happen over here? The leftmost non-terminal is T. So this T is going to be converted to F first of all. See, this is also T, but we are not going to convert them together. T derives F. Again, how many non-terminal you have on right side? 3. So left should be derived first. So this F will be derived to ID. Because F derives ID. Now how many non-terminal you have? 2. Which one is left one? This one. So that will be handled first. So this F will be deriving to ID. Because F derives ID. Now how many non-terminal you have on right side? A single. So anyhow that is going to be handled. So now ID multiplied with ID plus T will be converted to F. T will be deriving to F. And finally how many non-terminal you have? Single. So that is going to be handled only id plus f derives to id. Simple. We have achieved this leftmost derivation, right? You can write over here leftmost derivation. LD or LM, anyone can be written. Either you can write LD leftmost derivation or LM leftmost, that can be written over here. Let us take one more example so it will be more clear. id plus id divided by id minus id. Suppose this is our expression and you have to apply leftmost derivation. So what will happen? First of all, we will be giving precedence. This is the highest precedence, second highest precedence, third highest precedence. Okay. So this is deciding in which sequence the operators are going to be introduced. So which rule you have to pick up first? This one. So E derives E minus T. That is the first rule we are going to use. Justification, E derives E minus T. Okay. How many non-terminals you have on the right side? 2. Which one is left one? This. So that should be derived first. Okay. So which next operator you require? Plus this one. So this E should be deriving you E plus T. Because E derives E plus T. Okay. So this is derivable from E. How many non-terminals now you have on right side? 3. Which is leftmost? E. It should be derived first. Now see, actually you require a division which should be here. So you will be tempted to derive this T, but no, you cannot derive this T unless this E will be deriving to ID. What is the rule? Whenever you have more than one non-terminals on the right side of the production, the leftmost non-terminal must be derived first. What is leftmost? E. Do you require any operator on left side of plus? No, it should be ID only. So we have to convert this E to ID. So E derives to T because E derives to T. This T derives to F. T derives to F. And this F is deriving to ID also. Yes. Now, how many non-terminals you have on the right side of the production? 2. Which one is the leftmost? This. So it should be handled first. Are you getting this? Now what you require between plus and minus? We require a division. So this is rule we are going to introduce. So ID plus T derives T divided by F. Because T derives T divided by F. Now how many non-terminal you have on right side? 3. Which one is leftmost? This one. So that should be handled first. So ID plus, if you handle these first, it should be converted to F. Because T derives to F and F should be converted to ID. ID plus ID divided by F minus T because F derives ID. Now how many non-terminal we have on the right side? 2. So left should be handled first, F1. So ID plus ID divided by ID minus T because F derives ID. Finally, how many non-terminal we have on the right side here? A single. So that should be handled first. So ID plus ID divided by ID minus F because T derives F, and again there is a single non-terminal on right side which only we are going to handle now. So ID plus ID divided by ID minus ID because F derives ID. So that is how leftmost derivation is going to be applied. Yes, leftmost derivation. So what is important? Justification. Writing this justification in bracket is very, very important. Now using this we can draw even parse tree also. We know how to draw parse tree. Each and every rule should be applied in sequence. First of all, E derives E minus T. Then the next rule that we have applied is E derives E plus T. Then the next rule we have applied is E derives T. This T derives F. F derives ID. See, leftmost derivation. In the parse tree you don't have timestamp, so you won't understand whether it is leftmost derivation or rightmost derivation. But yes, when you show the parsing procedure, derivation procedure, it will be very clear. So that is the rule. Then next you have to apply is this t should be converted to t divided by f. Then next is t is deriving to f is deriving to id. Then this f is converted to id, and finally this t will be converted to f and f will be converted to id. So this is path tree for this. So what we have understood, for leftmost derivation, for one expression there can be two different derivations possible, deriving the same expression. One is leftmost derivation, second is rightmost derivation, but both leftmost derivation and rightmost derivation both will end up having the same parse tree. Parse tree will remain same. What is rightmost derivation? Let us try to understand that. What is right? We will be taking the same example now, because we have understood leftmost derivation, then rightmost derivation is just the reverse. What is the case of leftmost derivation? We are going to reverse in rightmost derivation. Whenever you have more than one non-terminal on right side, the rightmost non-terminal must be handled first, then it is rightmost derivation. Simple. So let us see with example. The first operator I am going to introduce again here is minus. So it derives e minus t. Simple. Now what we are going to do next? How many non-terminal we have? 2. Which is the rightmost? T. We are going to apply rightmost derivation now. Rm. So which one is rightmost t? It should be reduced first. Now on right side of t, what you require? id only. Minus what you require? id only. So this t will be converted to f, because t derives f. This is e derives e minus t. We should have because also. Okay, fine. How many non-terminal we have? 2. So right should be derived first, because this is rightmost derivation. So f will be deriving to id. This is minus, I am sorry, because f derives id. How many non-terminal we have? Only one, that is e. So that should be now derived. So what we require on left side of e? The second operator we are going to apply is plus. So e plus t minus id. Now how many non-terminal we have on right side? 2. Which should be applied first? Rightmost. Rightmost is t. What we require in the place of t? We require t divided by f. So this is e derives e plus t. So what we are going to do? This t should be reduced for derived first. T is going to derive division. So e plus t will be deriving this minus id. Okay, very good. T derives t divided by f. How many non-terminal we have on the right side? 3. Which one is rightmost? This one. So it should be derived first. So e plus t divided by f derives id, because f derives id. This is rightmost derivation. How many non-terminal we have now? 2. So rightmost should be derived first. This is rightmost. So operators, all operators have been introduced. Yes, we have plus, division, minus. So this t will be converted to f. T derives f. And this f will again to non-terminal. F is going to be derived first. E plus id divided by id minus id. So f will be deriving to id first. How many non-terminal we have on the right side? A single, that is e. What we require on the left side of plus? id. So e will be first of all converted to t. E derives t. Then t will be converted to f. T derives f. And then finally f is going to be converted to id. So this is called rightmost derivation. Yes. So do you understand the derivation process is different than the previous one? The answer is going to be same. So what we concluded, the same expression can be derived 2 ways. Leftmost derivation, rightmost derivation. The method can be different, but the parse tree which you are going to generate is same. Why? Because while derivation in steps you can see the difference, but in case of parse tree there is no time stamp. Which operator is applied, derived first, which non-terminal is derived first or later, you cannot see from the parse tree. and hence for leftmost derivation and rightmost derivation the parser is going to be same. So this is all we have understood about leftmost derivation and rightmost derivation. So in next lecture we are going to start with the top-down parsing, and the first parser which we are going to discuss is LL1 parser. Now if we talk about top-down parsers can never work with left recursive grammar. If we will apply left recursive grammar to top-down parsers, they will end up in having infinite loop. So the first thing we are going to discuss in next lecture is elimination of left recursion. Keep watching and please solve the examples which I am solving on the board as well as the examples which I am giving you in assignment. Ask if you have any query, submit your answers, check the solutions which I am uploading in Google Classroom, and keep studying, stay happy and healthy. Thank you.